Remember that iconic scene in Ice Age where Scrat causes a continental drift? Well, Mother Nature is pulling off her own version of continental reshuffling, and this time it's happening right before our eyes. Welcome to the incredible story of how Africa is literally breaking apart right before our eyes. In a geological event that sounds like it's straight out of a sci-fi movie, the African continent is slowly but surely splitting into two. This isn't the work of fictional prehistoric squirrels or movie magic. It's a real, ongoing process that's reshaping our planet's geography. Today we're diving into this fascinating phenomenon. Stay tuned to learn all about how Africa is splitting into two continents. Africa's tectonic drama. To comprehend the incredible phenomenon of Africa potentially splitting in two, we must first set the stage by understanding the basics of plate tectonics. Our planet's outer layer, the lithosphere, is composed of several large plates that float atop the semi-fluid mantle beneath. These plates are in constant, albeit slow, motion, moving at speeds comparable to the growth of your fingernails. The African continent, long thought to sit atop a single tectonic plate, is now understood to be undergoing a dramatic change. Evidence suggests that this massive landmass is slowly breaking apart along what geologists call the East African Rift System, EARS. This rift is essentially a crack in the Earth's crust that extends over 3,500 kilometers, 2,174 miles, from the Red Sea in the north to Mozambique in the southeast. The East African Rift. The East African Rift is not just any ordinary crack in the ground, it's a complex system of rifts, faults, and volcanic activity that's been shaping the African landscape for millions of years. This rift system is responsible for creating some of Africa's most iconic geographical features, including the towering peaks of Mount Kilimanjaro and Mount Kenya. The rift began forming approximately 25 million years ago, but its effects are still very much ongoing. It's along this rift that scientists believe Africa is slowly splitting into two separate plates, the Nubian plate to the west and the Somali plate to the east. This geological process is not just of academic interest. It has profound implications for the future of the continent, potentially reshaping its geography, climate, and even political boundaries over millions of years. The Kenyan Crack. In March 2018, the world received a stark reminder of the ongoing tectonic activity in East Africa. An enormous crack suddenly appeared in southwestern Kenya, stretching for several kilometers and even swallowing a section of the Nairobi-Narok Highway. This dramatic event reignited public interest and scientific debate about the future of the African continent. While initial reports linked this crack directly to the continental split, further investigation revealed a more nuanced story. Geologists now believe that this particular fissure was likely a pre-existing crevice filled with volcanic ash from past eruptions. Heavy rains caused the waterlogged ash to collapse, exposing the crack. However, even though this specific event wasn't a direct result of continental rifting, it served as a powerful reminder of the dynamic geological processes at work beneath our feet. Mechanics of continental breakup. So, how exactly does a continent split in two? The process begins deep within the Earth, in the hot, semi-fluid mantle that lies beneath the rigid tectonic plates. Current theories suggest that plumes of heat rising from the mantle are causing the lithosphere beneath Kenya and Ethiopia to dome and stretch. As the lithosphere thins, it becomes more susceptible to cracking. This has led to the formation of numerous faults and fissures along the East African Rift. From above, these features appear as deep crevices and elongated basins, separated by regions of higher elevation. The process is also accompanied by significant volcanic activity. Large-scale eruptions, known as flood basalts, have occurred along the rift, with lava gushing from emerging fissures like floodwaters. This volcanic activity not only shapes the landscape, but also provides further evidence of the thinning lithosphere and the upwelling of material from the mantle. Measuring the split. One of the most fascinating aspects of this continental breakup is that we can actually measure its progress. Using GPS technology, scientists have been able to track the movement of the Nubian and Somali plates with remarkable precision. Current measurements indicate that these plates are diverging at an average rate of about 7 millimeters, 0.2 inches per year. While this might seem slow by human standards, it's actually quite rapid in geological terms. Over millions of years, this steady movement can result in dramatic changes to the landscape. To put this in perspective, if we could fast forward millions of years into the future, we might see a very different African continent. The rift could widen significantly, potentially allowing oceanic waters to flood in and creating a new sea separating East Africa from the rest of the continent. The future African landscape. As we peer into the geological future, the potential changes to Africa's geography are both exciting and profound. If the rifting process continues as it has been, we could see the emergence of a new ocean basin in what is now Eastern Africa. Countries that are currently landlocked, such as Uganda and Ethiopia, might find themselves with new coastlines. This could have significant implications for trade, economics, and geopolitics in the region. New maritime routes could open up, potentially transforming these nations into important ports of call. Moreover, the creation of a new ocean would dramatically alter the climate and ecology of the region. Areas that are currently arid could become more humid, potentially leading to changes in vegetation and wildlife distributions. However, it's important to note that these changes won't happen overnight. The complete separation of East Africa from the rest of the continent, if it occurs, is estimated to take anywhere from 5 to 10 million years. So while we can observe and measure the process, none of us will be around to see its final outcome. Geological precedents. While the idea of a continent splitting in two might seem extraordinary, it's actually a process that has occurred multiple times in Earth's history. The most famous example is the breakup of the supercontinent Pangaea, which began about 175 million years ago. This massive landmass, which contained all of today's continents joined together, gradually split apart over millions of years. The separation of South America from Africa, which created the Atlantic Ocean, is a particularly relevant comparison to what's happening in East Africa today. In fact, the Red Sea and the Gulf of Aden are examples of rifts at more advanced stages of evolution than the East African rift. These bodies of water represent areas where continental crust has been stretched and thinned to the point where it has subsided below sea level, allowing oceanic waters to flood in. By studying these precedents, scientists can better understand the processes at work in East Africa and make more accurate predictions about its future. The debate continues. Despite the wealth of evidence supporting the idea of Africa splitting in two, there are still many uncertainties and debates within the scientific community. Some researchers question whether the rifting process will continue at its current rate, or if it might slow down, or even stop entirely. There are also debates about the exact mechanisms driving the rifting process. While the mantle plume theory is currently the most widely accepted explanation, other factors, such as far-field stresses from plate movements elsewhere on the globe, might also play a role. Moreover, the complex interplay between geological processes and climate adds another layer of uncertainty. Changes in rainfall patterns or glacial cycles could potentially influence the rate and direction of rifting. These uncertainties highlight the need for continued research and monitoring in the region. Advanced technologies such as satellite imaging, seismic monitoring, and computer modeling are providing scientists with increasingly detailed data about the rifting process. Implications for human society. While the potential splitting of Africa is primarily a geological phenomenon occurring on timescales far beyond human lifespans, it nevertheless has implications for people living in the region today and in the near future. The East African rift system is already influencing human activities in various ways. The rift valleys created by the process are often areas of fertile soil, making them important agricultural regions. However, they're also prone to earthquakes and volcanic activity, posing risks to local populations. The rifting process also influences the distribution of natural resources. As the crust thins and cracks, it can create pathways for minerals and geothermal energy. Many of the region's valuable mineral deposits are associated with the rift system. Looking further into the future, the potential creation of new coastlines could have profound economic and political implications. Countries that gain access to the sea could see new opportunities for trade and development. However, this could also lead to new geopolitical tensions as nations grapple with changing borders and resource distributions. The East African Rift and Global Tectonics. While the East African Rift is a remarkable geological feature in its own right, it's also part of a larger global system of tectonic activity. Understanding how this rift fits into the bigger picture can provide valuable insights into Earth's overall dynamics. The East African Rift is part of the Afro-Arabian Rift system, which extends from Turkey to Mozambique. This larger system includes the Red Sea Rift and the Gulf of Aden, which are more advanced stages of the same process we're seeing in East Africa. On an even broader scale, the rifting in Africa is part of the ongoing reorganization of Earth's tectonic plates. As some continents break apart, others are colliding. For example, while Africa is potentially splitting, India continues its slow-motion collision with Asia, pushing up the Himalayas. This global perspective reminds us that while we often think of the Earth as static, it's actually in a constant state of change. The African rift is just one part of this ongoing planetary evolution. The potential splitting of Africa is a testament to the dynamic nature of our planet. It reminds us that the Earth is not a static stage on which human history unfolds, but an active participant in shaping the world we inhabit. As we continue to study and understand these processes, we gain not only scientific knowledge, but also a deeper appreciation for the incredible, ever-changing planet we call home. Now it's time to hear from you. What are your thoughts on Africa potentially splitting into two continents? Does this geological phenomenon excite or concern you? If you lived in East Africa, how do you think this gradual change might affect your daily life or future plans? What other geological events around the world do you find fascinating? Share your ideas, questions, and insights in the comments section below.